Welcome to this presentation on integers. Integers are very important, and as you study through algebra, you need to make sure that your understanding of integers are intact. So let's look at a few examples of integers, starting with problems at the end of your book 0.1. So we have number 2, 4 minus -1. Remember, with integers, a negative times a negative is a positive. A negative times a positive is a negative. A positive times a negative is a negative as well. And a positive times a positive is a positive. Notice that when the signs are the same, you get a positive. And when the signs are different, you get a negative. So when you're given a problem like 4 minus -1, we need only one sign in between the two numbers in order to simplify this problem. So what do we need to do? We need to take this negative here and this negative here and allow them to interact. And what happens when they interact? We get 4 plus 1, which is 5. So remember the rules. A negative times a negative is a positive. Negative times positive or positive times negative will be a negative. And a positive times a positive is a positive. So that's something that's very important to keep in mind. Now we're going to look at another example where we have -6 plus 8. So we have -6 plus 8. Now remember, with the commutative property of addition, you could technically move numbers around. Now, in this case, you have a negative number here. So if you were to move that 8 in front of it, you're taking the sign along with it, and that's how you get 8 minus 6. The important thing to keep in mind is that there is no commutative property of subtraction, right? So we have to remember that. However, we know that we can move numbers around with their signs consistently and get the answer we need. But let's say you don't want to move it around, right? Let's say you want to look at this problem the way it is. You look at the 6, it has a negative attached to it. So you know that your final answer is going to be negative because there is, I apologize. Your final answer is going to be positive because your -6 is, your 6 is negative, which by itself 6 is less than 8. So that's why in this case it's positive. I apologize. I was trying to distinguish between that and if you had this case. -8 plus 6. With -8 plus 6, the 8 has the negative attached to it. So you know that you're going to have a negative and then it's going to be -2. But here's the pattern. One thing I want you to notice. The 6 and the 8, right? You look at the numbers individually and then you look at the signs next to the numbers. Then you know before you even start doing the problem if you're going to end up with a positive or if you're going to end up with a negative number. But as far as the interaction between the two numbers, this is just like saying 8 minus 6 over here. And this one is in a similar way saying 8 minus 6. Here's the catch. You would have to factor out that negative and then you would be able to write it this way. That's one way to look at the problem. You could take out a negative from both the -8 and from the 6. This is a different approach that you'll be learning later on. But I just wanted you to be aware of the fact that when you look at two numbers, like if somebody said 120 minus 180, we know the interaction between 120 and 180. If it was 180 minus 120, we know it's 60. But we have a negative in front of the bigger number, so our final answer has to have a negative in front of it. So in this case, it's -60. Let's look at a few more problems from this section. We have number 20, -5 plus 7. -5 plus 7, we're looking at -5, right? And we're seeing that it has the negative attached to it and the 7 is positive. So 7 minus 5, which we know is 2, that would be similar reasoning. So -5 plus 7 would give us a 2. Think of it this way. You have $10 and you go to the store. You want to buy something, but it's $20. You notice that you are in the negative if you want to buy it. At that point, you will owe $10 because you don't have enough to cover the cost of $20. So think of it, if you need to, as cash, right? This is the price of something, and this is what you essentially have, right? Let's say, or actually, you can look at it the other way around, depending on the circumstance. If you have $7 and you buy something that's $5, then you will have $2 left. But if you have $5 and you want to buy something that is $7, you are $2 in the negative. So remember, if you need to use money to remember, you can use money to help you. Another example, 8 minus -1. Again, we can't have two signs in simplifying, so we need to simplify this portion first. And negative times a negative is a positive. So 8 plus 1, and the answer is 9. How about number 30? -3 plus -5. Again, we look at the positive and the negative, and we say we have to simplify the positive and the negative before we can fully take care of the problem. So that becomes negative 3 minus 5. Very good question here. What happens when you have a negative and a negative? Negative 3 minus 5. Well, negative 3, let's say someone already owed $3, and then they found out later, oh no, you owe $5 to somebody else. Well, guess what? That means you owe a total of $8. So that becomes negative 8. This is how we deal with problems where we have a negative, like negative 6 minus 9. In one sense, you can add the 6 and the 9 together, and then just remember to put a negative in front of your answer. Integers are very important, so make sure that you do all the practice that you can. Do all the odd problems here, and make sure you're very comfortable with doing all these problems. Let's look at two different things about integers: multiplication and division. Remember the rules that I mentioned earlier. A negative times a negative is a positive. A negative times positive is a negative. A positive times a negative is a negative. And a positive times a positive is a positive. So for the rules that I've given you for multiplication, those rules will also work for division. So for example, if someone says, what is 7 times negative 5? Or they can write it like this. Okay, so you can put the 7 dot, like a dot here, and then minus 5. Or you can put a parenthesis around the negative 5. The answer is negative 35 because this is a positive times a negative. Remember, when the signs are different, your final answer will be a negative. So that's how we deal with number 32. 7 times negative 5, we get negative 35. Number 34, a negative 7 times a negative 2, that gives us a positive 14. Because we had a negative and a negative multiplying together, we get a positive answer. How about negative 6 times negative 1? We have two negatives, so what do we expect? We expect a positive as our final answer, and that will be a positive 6. Or you can just write it down as 6. You don't have to put the positive sign in front of the 6. And then let's look at two more problems. Negative 2 times negative 2. We have a negative and we have a negative. So what do you think we'll get? Positive 4. Very good. Or just a 4 by itself. So just remember, when the signs are the same, you get a positive, and when the signs are different, you get a negative. How about let's look at the quotient now. Find each quotient from number 46 to 59. Number 46 is 30 divided by negative 10. Remember that you have a positive divided by a negative, so your final answer there would be a negative 3. Number 50, a 30 divided by 6. Well, we know that it's just going to be straightforward division that you've done in PreAlgebra, and that will be 30 divided by 6, which is 5. And let's look at two more problems. Number 54, 80 divided by negative 8. 80 divided by negative 8. So you have a positive divided by a negative. Remember, the signs are different, so our final answer we know is going to be negative. So that's negative 10. And finally, number 60. 54 divided by negative 6. Similar situation. We have a positive divided by a negative. We'll end up with a negative 9. If the signs are the same, like negative 10 over negative 2, we will get a positive as our answer. I hope this is helpful. Feel free to do all the odd problems from 0.1 and have a wonderful day.